everyone. Today we are discussing about question number 10 of Cbse sample paper, which is an optional part of question number 10, and it is also a very important with the equation of plane. If we know a point and the plane which are parallel to two given lines. So now first we will read the question, and the question is, find the vector and Cartesian equation of plane containing the point I plus 2j minus k and parallel to the line this r vector r is equal to I plus 2j plus 2k plus s 2i minus 3j plus 2k, and another line is vector r 3i plus j minus 2k plus t and bracket I minus 3j plus k. So this is the question, and we want to find the equation of plane. For suppose this is our plane, and suppose these are the two lines which are parallel to this plane. One line is this, and one is this line, and second is this line. So these two lines suppose which are parallel to the plane. So now we have to find the vector which is perpendicular to the plane. Suppose this is a plane. So now only we want to find the vector which is perpendicular to the plane. If we find it, then we can find the equation of plane. So actually there are again a concept of vector product which we will use in this question, because this plane is parallel to two given lines. Let us assume this is line 1, this is line 2, then this is line 1 and this is line 2, and plane parallel to these two lines. Definitely normal vector which is always perpendicular to the plane is also perpendicular to line 1 and also perpendicular to line 2. So only we have to find the normal vector of plane, and if we find it, then equation of plane will be definitely we can solve, because already one point of plane is given, and the requirement only we want to find the normal vector of plane. So in this question, because the plane parallel to these both lines, it means we will directly write normal vector which is a perpendicular to the plane, perpendicular to line 1 and perpendicular to line 2. First step we will write it, and line 1 is parallel to this vector, line 2 parallel to this vector. It implies we can find vector n by the cross product of direction vector of lines. So direction vectors of lines, it means this is a vector b1 into vector b2, and their cross product will be represent the normal vector of plane. So this is the way to find the normal vector of plane. Now we will again, in previous session also we have used cross product of two vectors. So now the cross product, generally we will use determinant method. I, j, k are the first row elements, and b1 vector, it is b1 vector, their coefficients I, j, k coefficients 2, minus 3, 2, and the coefficients of vector b2 of ijk are 1, minus 3 and 1. So now simplify it. Now when we simplify it, then it will be minus 3 with I, minus 3 plus 6 means 3i cap with j 2 minus 2 0 and with k minus 6 plus 3 means minus 3k cap. So this is the normal vector for this plane, and which is vector n cap. In simply, vector n is a direction vector of normal. So again vector n can be written as I minus k also. Okay. So now the equation of vector equation of plane, we know it. Vector equation of plane represented by vector r dot vector n is equal to t. This is the vector equation of plane. First we will write it. Vector equation of plane. And vector n already we have found it by this. Vector r is any point of plane, and t is constant by find if we know any one point. So vector on, we know that this vector passes through this given point. So now we can find d by, in place of r put this vector, means I plus 2j minus k dot vector n. In place of vector n we will write 3I minus 3k is equal to d. The dot product of two vectors, we will use the dot product. It will be 3 plus 3 means 6. You can see here 1 into 3 3, 2 into 0 0, minus 1 into plus 3 minus 3 plus 3 means d is equal to 6. So d is equal to 6. Now the vector equation will be write as vector r dot 3I minus 3k is equal to 6. We can also divide 3 because 3 can be common scalar multiple of vector, and 6 will be. So now it will be better. Vector r dot I minus k is equal to 2. This is our first answer. And now we know how we will convert it in Cartesian product. In place of vector r, we will write xi plus yj plus zk. If we write it in place of vector r, then the solution will represent Cartesian product. Now their multiplication, and then it will be x minus z is equal to 2. So this and this are answer of this question here. This is vector equation of plane. This is Cartesian equation of plane. So it is also a very important part of equation of plane. If we know one point and the lines which are parallel to the plane, so we can find the vector equation. Thank you.